The purpose of today's lesson is finding slope from a context. So they're just giving us a quick summary of what the story's about. Gourmet jelly beans cost $9 for 2 pounds. That's all we're given. And now we have to fill in the rest of this stuff. We have to complete the table. We have to graph and label the relationship. We have to find the slope. We have to write the slope of the line as a rate of change that describes what the slope means in this context. We have to write an equation to find the cost of any amount of jelly beans, and we have to find out why is the data graphed only in the first quadrant. So we have to answer all these questions. Okay, let's start with the table. Well, we know it's $9 for 2 pounds. So here's $9, so obviously 2 is going to go here. I could do that one. So we may have to do a proportion each time because it looks like, let's start with this one. This one looks a little bit easier. If it's 2 to 9, and probably it would be best to write it like we would be writing the slope, which is 9 to 2. So it's 9 to 2. We need to figure out what goes with the 3. So we could cross multiply, which is 27 equals 2x. Remember how you did this previously? And then divide both sides by 2. And that's going to give us 13.5, which is really $13.50. We kind of want to think of it in terms of money. So we would have to do this each time. 9 to 2 equals what to 4? So we would do, once again, 36 equals 2x. Half of 36 is 18. I wonder if we can find a pattern. What do you think? That might be an idea, or we can just keep using this. So go ahead and figure out the rest of these, and then I'll come back and we'll see if we get the same answers. Okay, so now we have our numbers. We've got our pounds, we have our total cost. We've got a nice table going here. And you had to switch it up here. I don't know if you noticed that, because normally I was putting the X on top, but on this next one, I had to find a different number, so I had to put the X in the denominator. I hope you got that. All right, now we're going to graph the relationship. Okay, remember, this is your Y, and this is your X. So your cost is going to go on the y-axis, just as a refresher, and the x-axis, obviously, is the other one, and this is going to be the pounds. So this is the number of pounds. So we have to plot these points. So we're going to number all these, and we're anywhere up to 20. So probably going by 2s, and it works. And then, of course, on this other one, let's go by 10s because that kind of makes sense. Say hi, Molly.
Hi, everyone.
That's my daughter, Molly. I'll continue in a bit. Okay, so now we're going to continue labeling. Sorry, the interruption. I had to talk to my daughter. All right, so we're going to go up to 50, and then we're going to plot these points. All right, so we could go 2 to 9. And of course 0, 0 we're going to start at. And then 4 is 18, so there's 20. Let's jump all the way to 12, 20. 12, 14, 16, 18, 20. And that is at 90, 50, 60, 70, 80, 90. So that's this point. So sometimes I'll just skip a little bit so I can get a good idea of where my line should go. And this shows the relationship. Okay, what is the slope of the line? Well, the slope of the line is your rise over run. So we could use the 2 points and do a triangle, or we could just know that it's 9 over 2. Write the slope of the line as a rate of change that describes what the slope means in this context. All right, so we have 9 over 2. Well, the rate of change is 4.5 over 1. So that's the same as the unit rate. What does that mean? For every pound of jelly beans that are bought, it costs $4.50. So for every pound bought, it cost $4.50. Okay, write an equation to find the cost for any amount of jelly beans. Okay, we have to go back to our previous lessons, but that's okay. We could write y equals, and we could use the unit rate, which is 4.5x, or we could use the slope. Either way, it's the same thing. Why is the data graphed only in the first quadrant? Well, it's impossible to have buy a negative amount of jelly beans. So look at how we put all this together. You say, when are we ever going to use this in life? Well, look at how we're using this. This is just about a cost. And we can find a graph. We had to find the slope, the rate of change. Okay, let's take a look at the next one. Kaylin takes the same amount of time to solve each of the equations on her math homework. She can solve 10 equations in 8 minutes. So 10 equations in 8 minutes. So I just am going to write that, 10 equations. And this is my equations, and this is my minutes. Okay, look at how that refers here. So equations is 10 per 8 minutes. Oh, look, here's an 8, so I know this has to be 10. Okay, so now we have to find all these others. So we have our proportion as 10 over 8. Well, let's try a different method. What if I simplified that and divided each by 2? Wouldn't that become 5/4? Ooh, look, I've got a 5, so that's going to be a 4 there. And then I could just, sometimes you can just kind of strategize. Half of 4 is 2, so I would do half of 5, and that's 2.5. Well, this is working out nicely. Okay, then maybe I'm going to have to do a little math here and do 10 over 8 equals 15 over something. What is that going to be? Can we just figure that out? Well, I could go back to this 5/4. That might help me. Because look what happens. 5/4, I'm going to triple my 5. Oh, that's a 4. So I'm supposed to triple my 4. So that's going to be a 12. So that's one way to think of it and to do this. Okay. What if I found this one and I multiplied by 4? I would have to multiply this one by 4. So I'm strategizing here, and that gives me 16. And this one was times 4, that's 20. And then 4 times 5, so I'm multiplying the 4 by 5, so I'd have to multiply the 5 by 5 and get 25. This seems a little more efficient. So if you can find the simplest rate, then you can find your other pieces here. And this one is the 5 is times 6. So the 4 would have to be times 6 is 24. Look at that. Got my table all figured out. Okay, now we have to graph this. So go ahead and write what you think should be on the graph, and I'll come back and we'll see if we have the same. Okay, you may have used different increments than I did. I went by 5s because I felt like, oh, I don't want to write all those things. Sorry if you hear that background noise. Got guys working at the house. All right, what is the slope of the line? Well, the slope of the line is the simplified version of what we started with. So we simplified. So here's our slope. What is the slope as a rate of change? So we're going to simplify 5/4, and that's 1.25 per 1. So Kaylin can solve, she can solve 1.25 problems per minute. Per minute. Okay, that's what that means. All right, what's our equation? Well, we're going to use our slope, or our rate of change. Remember, that's where that goes. Or you could write it as y equals 5/4 x. Okay? Okay, we've got another problem on this next page. Mr. Irving and Mrs. Henriksen pay babysitters differently. Examine the table. Describe the difference. Okay, there's hours. There's Irving. And then we have Henriksen. Okay, describe the difference. Well, for 1 hour, it looks like Irving pays $9, but Henriksen pays $12. Okay, I'm going to go work for Henriksen. How about you guys? What do you think? Are both relationships proportional? Well, I guess we're supposed to describe the difference. I'm going to pause and write it. Uh-oh, my bad. I didn't even notice this. Look at this. Henriksen, for 0 hours, paid $4. So that's like you get a bonus just for showing up. But then it looks like for 3 hours, if you take the initial fee, that means you're going to get $24 per 3 hours. If you take away the initial fee, you're going to get $8. So my bad, Henriksen pays $8 an hour plus the $4 start fee. So kind of keep that in mind. But Irving, since it's starting at 0, Irving actually pays $9 per hour. And Henriksen pays $8 per hour plus the $4. Kind of keep that in mind. Are both relationships proportional? No. Because, remember, to be proportional has to go through, has to start at 0. So Henriksen is not proportional. Graph and label the two pay rates, 2 different lines. Okay. Go ahead and label and graph those. And I'll do that, and let's compare to see if we got the same. Okay, you can see the lines, and I did Henriksen. Notice Henriksen starting at 4. So don't start at 0 for Henriksen. What is the slope of each line? Irving is 9/1. Henriksen is 8/1. Okay, let's go back up here. Write each slope as a rate of change to interpret its meaning. So Irving, you're going to get $9 per hour, and Henriksen is going to be $8 per hour. Explain the y-intercepts. Okay, for Irving, the y-intercept is 0, and for Henriksen, the y-intercept is 4. Well, what that means is that Irving, there's not anything paid up front, but Henriksen pays $4 up front just for showing up. So you get that $4 right off the top. Is one babysitting job better than the other? Why not? Well, I guess it depends on how long are you going to babysit. Let's take a look at the graph. Because this is the hours down here. I should have labeled that. My bad. And this is the cost. So let's take a look. At 5 hours, if you're babysitting for Irving, which is blue, you're going to get $45. If you're babysitting for Henriksen, you only get $44. Okay? But look at hour 1. Hour 1 for Henriksen, you're going to get $12. But for Irving, you're only going to get $9. So it just depends on the number of hours you're going to babysit. Depends on number of hours as to who is better. Write an equation for each equation, or for each situation. My bad. So y equals 9x for Irving, but Henriksen, yeah, we know it's 8, but remember, you get a startup fee. So it just depends on the number of hours as to who is the best to babysit for. Okay, this concludes our lesson on finding slope with a context.